Okay, we're going to continue working on regression in this video, and I have up one of the problems that we did in the previous video, and we're going to continue from here. Last time we talked about how to run the regression using Excel, also how to interpret beta 1, right? And so in this case, given the results we have, let me get my pen working first. Given the results we have, we look at beta 1, which is right here. We then wrote out our regression line, and we said that, as you can read up here on the right hand side, when advertising increases by $1,000, because we're told in the problem that advertising is in thousands, sales increase by $58,000 on average. Okay, or you could say sales are expected to increase by $58,000. On your test, it's going to be imperative for you to either say expect or on average, because that does change the entire meaning of the interpretation, right? We're not saying that if you advertise $1,000 more, you're definitely going to get $58,000 out of it. You may only get $24,000. You may get $112,000, right? It could be above or below, but on average, we expect it to be $58,000 in sales per $1,000 in advertising, right? Okay. So what we haven't talked about yet is whether or not this is what we call a statistically significant relationship, okay, if there does appear to be a true linear relationship between these two variables. So we are going to work on that today, and this is hypothesis testing, okay? This is the same, we're going to go through the same methods that we went through when we were just doing regular hypothesis testing before exam 1, okay? All right, so what I want you to do, and I do think it's a great idea for you to do this alongside me, so if you need to pause the video, reopen the data, and run the analysis again, or pull up the data so that we can run the analysis again, then make sure you do so, okay? All right, so I'm going to go to data and data analysis, and I'm going to pull up regression. Now remember, if you are on a campus computer, you will have to download this add-on again. If you can't remember how, you can go back to last week's video. Okay? All right, so I'm going to do the exact same model we had before. My Y, my dependent variable, is sales. I believe that advertising explains sales, right? So that's my Y. And then my X is advertising dollars. So it should look like this. Ooh, I just realized this needs to be a 1 because I want to have my labels, right? Next week we're going to talk about multiple regression, and it'll be especially important to have labels at that point. Okay, I am then going to hit OK, and I'm going to get a new regression. Now these are the exact same results as we had before. I'm going to go over a few things with you, and then we're going to go through the hypothesis testing methods. Okay? All right. Then we're going to do like just a lot of examples in the book, because I really think once we get to regression, the best way is why I'm doing the screencast instead of the regular videos, because really the best way for you to get this information is through watching me do it and doing it yourself. Okay? All the data that I will use today either was in the folder last week or is in the folder for this week, so you should have access to all the data that I use. Okay, so last time we went over how to, figure out what the regression equation is. I'm going to write this again. So here we are predicting sales. So predicted sales is equal to, we want to do the intercept, right? Here's our intercept right there. Oops, kind of crossed it over there. 9.100 plus 0.58 times advertising. Okay, now this is the slope, right? This is the slope of, if we go back and look at the scatter plot right there, the beta 1 is literally the slope of this line, right? And it's small, right? It's 0.058. But we don't really know yet if this is significantly different from 0. Okay, so that's what we want to test for. All right, so there are 3 ways to do this. Okay, I want you to pay attention to 3 things. The first is the t-stat. The second is the p-value. And then the third is this lower 95, upper 95. Okay, these are the 3 columns that we're really going to focus on. We already know a couple things here, and I do want to go over them. Let me erase this so you can see it. Okay, a few other things I want to go over really quickly. So we know that this 9.1, this is the intercept, right? I know we went over all this last week, but it's always good to cover it again. The 0.058 is what we call the slope coefficient. And this is also, this is beta 1, right? And this is beta 0. And this predicts what will happen when we have a change in x, right? What happens when we have a change in x? And what we are now interested in is this slope significantly different from 0. A couple other things we know here. Our r squared, we've covered that several times, right? In this case, it's 0.6066. How do we interpret this? 60.66% of the variation in sales can be explained by advertising. Okay? This is relatively high, okay? 60.66% is a relatively high R squared. Not very, very high, but it is relatively high. Okay. Also, this shows us our number of observations. This is important. If you know you have 50 observations and for some reason that shows up as 12, you've got a problem, right? You have to have full data on all observations. So make sure that that number of observations in this output matches what you have. Remember, you need at least 30 for your paper. Okay. So we want to know whether or not this relationship is significant. And in particular, we are going to be paying attention to these where I'm highlighting in blue here. Okay. The one above, that's going to show the significance of the intercept, which is not important for us. We are interested in the significance of the slope coefficient. And what we are testing this whole time, and this is why it's so important to learn hypothesis testing. The null hypothesis that we are testing is that beta 1 is equal to 0. Always. Okay, this is always the coefficient, this is always the null hypothesis when you're running a regression. And so this would mean there is no significant linear relationship. And literally what that means is that the slope of this line cannot be distinguished from 0. Okay? So if this is our null hypothesis, then the alternative hypothesis, hold on for a second, for some reason it didn't work. The alternative hypothesis is that beta 1 is not equal to 0. Hopefully you'll remember me saying that the reason we were going to focus mostly on two-sided hypotheses is because this is what we would be testing for when we got to regression. Indeed, that's what we're doing. And so if we reject the null, then we're saying there is a significant linear relationship. Okay? So how in the heck do we determine this? Well, there are 3 ways, okay? Now, your book and on your test, sometimes it will give you an alpha value, but there's 3 levels I want you to be able to identify, okay? The 10% level, the 5% level, and the 1% level, okay? And we've already gone over in class that the critical value for the 10% level is 1.645. For the 5% level, it's 1.96, and for the 1% level, it's 2.58. And these are simply the values that you would find if you looked them up on the table. I showed it to you in class. Hopefully you remember that. But literally what it means, like if you look at a normal distribution and you have negative 1.96 and positive 1.96, it literally means that 5% of the distribution is in the shaded area. Okay, so 5% of the distribution is outside of 1.96 and negative 1.96, so on each side it's 2.5%. Okay, so you can just memorize these. I won't ask you to memorize too many things, but this is one thing I will ask you to memorize. Now, what you hopefully remember too, learning, is what the p-value is. The p-value is what is the probability that you're in this shaded region, okay? And if we have a small p-value, we reject the null, okay? Now, I'm going to go in and erase a little bit of this stuff so that I can keep it here, because this is really important. I want to make sure, you know, you guys need to take notes while I'm doing this as well. All right, let's do green here. Okay, so small p-value, reject the null, right? What is small? For the 10% level, you're looking for, well, let's start at 1% actually. That makes more sense. For the 1% level, you're looking for less than 0.01. Very small, okay? For the 5% level, and this is of significance, statistical significance, the 5% level of statistical significance, you're looking for it to be greater than 0.01, but less than 0.05. Less than or equal to. With each of these, let's say equal, less than or equal to. And then for the 10%, you want it to be between 0.05 and 0.10. Okay? All right. So, let's analyze these results. And we're going to just practice this time and time again. So there's 3 ways you can look at this. The first way we're going to look at, and just like I said before when we were in class, when you do this, you should get the same results no matter which way you do it, okay? So in the first method, oh gosh, what's going on here? There we go. Okay, so in the first method, we use the t-stat. For the 10%, we're looking for it to be greater than or equal to 1.645, 5% greater than or equal to 1.96, 1% greater than or equal to 2.58. Now we only, I don't want to word this exactly, we only state the most, the strongest relationship, okay, or the most significant. So 1% is the highest level. So like in this case, if we look at the t-stat here, we have a t-stat for beta 1. What is the test statistic equal to? The test statistic is equal to 3.926. And this is the same t-stat or z-stat, however you want to state it, that we looked at before, right? This was x bar minus the mean of x according to the null over the standard error of x bar. Remember that formula? This is the exact same here. If you look at the t-stat, if you were, now think about it. So with regression, let me take this forward real quick. With regression, we have beta 1 minus beta 1 according to the null divided by the standard error of beta 1, right? So if you look at this formula, what is beta 1 according to the null? That's 0, right? So we have beta 1, which in this case is 0.058 minus 0 divided by the standard error. And sure enough, if you look over here, look right here. If you do this math, if you were to do 0.0582 divided by 0.0148, you would get this t-stat. Okay, so indeed it is that relationship. Okay, so we want to look at the t-stat. In this case, it's 3.926. This is greater than 2.58, and so this tells us to reject the null. which means that it is significant. Okay, this means it's significant at 1% level, because the 1% is the most strict level, has the highest standard, so we state that one. All right. Second way we can look at this, and once again, we're going to practice this over and over again over a couple videos, so be patient with yourself. If it doesn't click immediately the first time, that's okay. Second thing we're going to look at is our p-value up here, and the p-values we're looking for are right here, right? So our p-value is 0.0028, and that is certainly less than 0.01. So that tells us that it is significant at 1% level. Like I said, you should always get the same result. Okay? You should always get the same result between methods 1, methods 2. Method 3, I don't suggest you really use this one just because the way the regression is set up, it's not really set up to do this way. But actually, I'm going to go back over here to sheet 1 and do, I'm going to do the regression one more time. And when we come in here, you can ask, you see right here where it says confidence level. Oh, it messed up. Let's see. Let's see here. If you click here confidence level and you put in 99% and hit OK, here are the results. Now let me go over what we just went over again on this nice, pretty clean sheet. And in this case, here's what we're going to be looking at, because it turns out that it is significant at the 1% level, right? So we are going to be looking at the t-stat and the p-value here, and then this confidence level right there. Okay? So our 3 methods, the first was the t-stat, right? And in this case, the t-stat associated with beta 1 is 3.926 because it is greater than 2.58. We can say the relationship between advertising and sales, right, is significant at the 1% level. Okay? All right. Number 2 was the p-value, right? And the p-value we're looking to see, is it less than 1%? If yes, it's significant at 1%. If no, then we say, okay, well, is it less than 0.05? Is it less than 5%? If yes, it's significant at that level. If not, then we say, is it less than 0.1, 10%? If yes, it's significant at the 10% level. If not, then it's insignificant, okay? If not, then we fail to reject the null. We can't say the slope is any different from 0, and so we're left right where we were to start. Okay, so with the p-value here, it is equal to 0.0028. And so since it is, what just happened there? So since it, oops, let me come over here and get this. It is less than or equal to 0.01. We can say, gosh, I don't know why that's doing that. We can say it's significant at the 1% level. All right, the third one, so those are the 2 we had already gone over. The third one is the confidence interval. And you may remember me saying before that if the mean, according to the null, is in the confidence interval, then we fail to reject the null. If the mean, according to the null, is not in the confidence interval, then we reject the null. Okay, that's exactly what we do here. So in a regression, we are always looking to see if 0 is in the confidence interval. This is the confidence interval right here. And at the 99% level, we can see that it's entirely positive. And here at the 95% level, same thing, it's entirely positive. So the way I would word this is, since 0 is not in the confidence interval, I'm going to say the 99% confidence interval. And we'll see one, hopefully, as we go through these results tonight, that where the 0 is in that interval. So 0 is not in the 99% confidence interval. We reject the null at the 1% level. So it's significant at the 1% level. You should always, always, always get consistent results across these three methods. Okay? Always. If you don't, there's something wrong. So it's always good to use more than one, in my opinion. Anyway. Okay? Alright. Let's do a practice problem. I'm going to start out with a new Excel file. You guys can do this with me, hopefully. Pull up a blank workbook. And I'm going to do this as problem 16.22 in your book. You're going to have some homework that will relate to similar problems, okay? 16.22, we have X and we have Y. And it says you've been given the following data. X, 1, 3, 1, 3, 4, 6, 9, 8, 10. And then the corresponding Y values are 1, 8, 15, 33, 75, 70, and 95. Okay? Part A says draw the scatter diagram. Does it appear that X and Y are related? If so, how? So let's do that first. I'm just going to select this data, then go to Insert and draw me a scatter diagram. And this is good. We already have X axis and Y axis correct. And does there appear to be a relationship? I would say, personally would say absolutely so, right? You can see that you could draw a line of best fit right through there, right? So it does appear to be a positive, and it does appear to be in a significant relationship. But part 2 says test to determine whether there is evidence of a linear relationship. Okay, so what does that mean? That means we're going to run a regression. So I'm going to go to Data, Data Analysis, Regression, and then for my Y, I'm going to select my Y range here. And for X, I'll get my X range. I'm going to leave this confidence level at 99%. I'm going to leave that for now. And then I'm going to hit OK. Alright, I am going to ask you to pause the video in just a moment. I want you to do a few things. Here's what I want you to do. Here are your assignments. Number 1, I want you to write out the regression line. Number 2, I want you to interpret beta 1. Number 3, I want you to test the significance of beta 1. So this is the hypothesis test that we just went over. And then 4, I want you to state and interpret R squared. Okay, so please pause the computer right now, pause the video, and do the problem, and when you come back, I'll have the answers for you. Okay? Okay, we're going to do each of these steps. Hopefully you paused the video and did them. If not, I really highly suggest you give it a try yourself. That's the best way for you to learn, is even if it's trial and error, even if you don't get it right the first time, to try it yourself and then move forward. Okay, so we don't know what x and y are in this case, so this makes it a little bit awkward. But for number 1, we have predicted y is equal to negative 21.387. Remember I said always go 3 decimal places, or 2 places after the decimal, plus 10.895x. Okay. Number 2, since we don't know what x and y are, this is a bit awkward, but the way we would interpret this is as x increases by 1 unit, we expect y to increase by 10.895, right? Okay. All right. Number 3, test the significance of beta 1. We've got 3 options, right? The t-stat, the p-value, or the confidence interval. I personally look at the p-value. To me, it is the easiest. It's the fastest one just to kind of glance at. So I'm going to look at the p-value. I do suggest, or when you're early on doing this, that you look at more than one way just to verify your results, just to make sure you're right. But here the p-value is equal to 0.000000165, right? That's the p-value. So this is certainly less than 0.01. So this means that there is the relationship between x and y is significant at the 1% level. Okay, and then number 4, state and interpret r squared. R squared's up here, right? It's very high in this case. R squared is equal to 0.9530, and so 95.30 of the variation in x. Oh, sorry, in y. That's bad. In y can be explained by x. Right? Erase that and rewrite it just so to make sure it looks fine. So 95.30% of the variation y can be explained by x. Okay? Alright, I'm going to stop this video here just because we're already close to 30 minutes, and I don't like to do too much at once because I know you guys have limited time to be able to sit around and watch videos. However, I will tell you that the next problem that I want you guys to look at is problem 16.12 in your book, 16.12, and I will post that data on Blackboard. And I want you to try to do both 16.12.12, I'll write these on here, 16.12, as well as, let's see here, 16.34. These use the same data. The data that I'm going to be posting is named 16.12. And if you'll go ahead and try those 2 questions, and then when you watch the next video, we'll go over those with you. All right? Thanks a lot.